Now we'll do the heat of solution, where we're going to just take solid ammonium chloride, dissolve it up in water to make the aqueous solution of ammonium chloride. We're doing this using the standard coffee cup calorimeter there. So we have our water in this double coffee cup. We have a thermometer going in through the lid. We have a little stirrer going in there. And the idea is that you're going to start your reaction, quickly put the lid on, stir it, measure the temperature. Okay, so we're setting up with 25 mils of water. That's how much water we've got. So that's in the pretty blue. Measuring the temperature, record it every 30 seconds so that we've got that starting temperature, more than one reading on that starting temperature. While we're letting that get there, we can weigh out 1.5 grams or so of ammonium chloride. We do need the exact mass, of course. Add the solid into the coffee cup, stir it, watch it, record the temperature every 30 seconds. Then for our data analysis, we need to plot a graph. And the whole idea of plotting that graph is it is the best way to get the temperature change. We know the initial temperature. We can use graphing techniques in order to get the maximum or minimum temperature. And then we use that to get the heat of solution. So took 1.42 grams of ammonium chloride. I measured its temperature every 30 seconds. So 22, 22, 22. At 2 minutes, 120 seconds, I added the ammonium chloride. Look, the temperature went down. Now, if the temperature is going down of the water, that means that the chemical process is absorbing heat. It's taking in heat. In other words, this is an endothermic process. So we'll deal with that in a minute. Anyway, then we keep measuring the temperature and so on and so on and so on. Got a bit bored after, what's this, 6 and a bit minutes. So now we plot out the time in seconds along the horizontal, the temperature in degrees Celsius, and you can see this is where we were measuring the temperature with nothing happening at 22. We added at 120 seconds, the temperature went down to 18.3 there, and then it started coming on up. Okay, now obviously this was the starting temperature of the water, but there was 30 seconds between us adding the ammonium chloride and measuring the temperature here, and you can see that of course as soon as the temperature's gone down, it starts warming back up again to get presumably to room temperature. So graphically, what you need to do to get the actual minimum temperature here is you draw two lines. The first thing you do is you say, well, I added at 120 seconds. So you draw a vertical line for 120 seconds, okay? And then you've got this, in this case, warming up part of it. Well, it started warming up as soon as you added the ammonium chloride and the temperature went down. So in order to get a much better idea of the minimum temperature, you take the best fit line for this warming up part and draw a straight line through that. Okay, so vertical line where you added it, line of best fit to go through the warming up process, the after you added it bit, and then where the two lines intersect, this is a pretty good estimate of what that minimum temperature would have been if you'd added the stuff and perfectly mixed it all together. Okay, and in this case we read it off this graph. Can't see it too well because it's just a little bitty Excel thing, but that minimum temperature 18.2 degrees Celsius. Okay, so here are the data we're going to need for the calculations. Mass of ammonium chloride 1.42 grams, initial temperature of water 22, minimum temperature 18.2. So let's do those calculations, right? This blue here associated with the temperature change of the water, starting temperature 22, minimum temperature 18.2, temperature change, it went down by minus 3.8 degrees Celsius. Now let's do the calculation in the green box here to get the heat change of the water. We need the mass of the water. Well, if you go all the way back to the process, the script, the procedure, that was 25 grams. Temperature change minus 3.8, 4.18 joules per gram per degree Celsius. Pop all that in, and the heat change of the water minus 397 joules. Heat change for the reaction, for the dissolving of ammonium chloride, is change the sign of that. So the Q for the reaction in gold plus 397 joules. Now we can do our molar calculation. We took, if you remember, 1.42 grams of ammonium chloride. Molar mass of ammonium chloride, 14 plus 4 plus 35.5 is 53.5 grams per mole. So the number of moles of ammonium chloride we have, 0.0265 moles. Then finally, 0.0265 moles had a heat change of plus 397. So to get the delta H of solution in moles, we want it as joules per mole. So joules divided by the moles equals plus 14,981 joules per mole. Divide that by 1,000, get it to a more realistic precision, and it's about 15 kilojoules per mole change. Again, please notice ultimately the same process. In this case, we had to use the graph to get the temperature change of the water. Once we got the temperature change of the water, same Q expression to get the Q of the water, change the sign for the Q of the reaction, figure out how many moles led to this number of joules, which will therefore help you get to the overall heat of solution.